So this is the midterm review solutions. This first one, directed line segment AB. Okay, so we're moving from A to B, and we want to partition the segment into a 3-to-1 ratio. Okay, so what we're going to have to know is, first, 3-to-1 ratio means there's going to be 4 equal parts on this segment. So use your straight edge, connect these, and we're going to try to see if we can split into 4 equal parts. Usually the slope will do that for us. What I mean is this. Okay, if we count, the run is 4, and the rise is 12. Okay, so if we want 4 equal parts, what we can do is we can take either one of them. The run, that's 4. If we divide it by 4, we get 1. So every time we move over 1, that's in the wrong spot, sorry. Along that line, if we use the straight edge, that's going to split it into one of the equal parts for us. And we want to move from A to B. So let's start from this way. Okay, A to B. So we're heading that way. All right, the rise is 12. So 12 divided by 4 is 3. So if we move over 1 and down 1, 2, 3, we land right there. Let's do that again. Over 1, down 3. Right there. Over 1, down 3. Right there. So forget that point. Okay, so what I've just done is, what you can see is we've got 4 equal parts here. Okay, now we want a 3. We want 1, 2, 3 of these, and then 1. So this is 3 parts. This is going to be 1 part. This location right here, it looks like it's 1, -1, is our point that will partition it into a 3-to-1 ratio. Okay, so we'll just call that P. All right, next. This is a volume question, so from the first chapter that we did this year. Okay, side W. So basically what we think of is, okay, we put, say, a stick right there, right? And we take this figure and we think about rotating it continuously, okay? Think about what'll happen there, okay? What we're seeing here, I hope, is it will take on the shape of a cylinder, where this is going to be the height of the cylinder. Yeah, that's the height of the cylinder, and that's going to be the radius of the cylinder. So that's what we're going to get. Okay, so they mean 360 degrees, kind of in 3D space when they say rotate the solid figure. Okay, all right, or solid the 2D figure to make a solid figure. All right, segment AB is the diameter of circle M. Circle M. Okay, so let's try to make, not bad. When they say circle M, they mean the center of the circle is M. Okay, let's see. The coordinates are -4, 3. Okay, so here's what I'll do. I'll get on the graph. Basically, this is a midpoint problem, believe it or not. Okay. What they're giving you is any circle. Anytime you have a circle and a diameter, it's going to go through the center. So we have a situation like this, right? They're telling us the coordinates of A. They're telling us the coordinates of the center, which is M. And we're going to kind of continue on to find B. So basically, the midpoint of AB is M. And that's essentially the problem. But let me go get a piece of graph paper, and then I'll do it on that. Okay, so back here again, coordinates for -4, 3 and 1, 5. So there's A, there's M. We know B is going to be in this range over here. All you got to do to find the other end of this problem is count up 2 over 5 and then repeat. So that's where B will be. Okay, it's a midpoint problem. Given the midpoint, find the other end. That location looks like 6, 7. There you go. Not bad. Okay, what is the length? So now we're kind of practicing second chapter, geometry basics. Calculating slope, calculating midpoint, calculating distance. It looks like this one's the distance one. All right. There's a formula, but we don't use that. We use a squared plus b squared equals c squared instead. The trick on this one, though, is that you have to imagine we have, okay, let's see, we have a situation like this. It's way off the graph, obviously, so they're trying to force us to use the distance formula, but we're not going to. If, let's just say this was the point negative 4, 2, and this was 146, 52. What would end up happening here on this problem is basically you have a rise and a run. Your run is the distance between the x's, okay? So how far apart are the x's? That's all you've got to consider. So from negative 4 to 146 is 150 steps. So that's going to be your run. Your rise is going to be your difference in y's, okay? That's just, you know, that's just the absolute value symbol. So 52 to 2 is going to give us a rise of 50. All right, so now we want this distance. We're going to use 150 squared plus 50 squared. I use D, you can use C, however you want to do it. So that is, if you type that in the calculator, 25,000. All right, and then once we square root both sides to try to get rid of the squared. Okay, we don't get a nice number, but it does say, kind of tells us to round. So type it in the calculator, you'll get 158.114. Nearest tenth one place is 158.1. So there's that one. Okay. We get time for maybe 1 or 2 more of these. All right. So which of the following statements is false? All right. Angle AED is 104. All right. So obviously we know that's not to scale, but we've got to listen to what it says, not what it looks like. So that's 104, that angle. All right, 180 minus 104, we're using linear pairs concept here, is 76. So if we use the linear pairs concept, those are 76-degree angles, and then of course vertical angles gives us 104 there. So far these are correct. We want the false one. All right, BEC, BEC. Let's follow the path there. B to E to C. So this angle here, and C to E to A. Those are adjacent angles is the claim, and that is true. We want the false one, so there we go. AEB, I'm looking at AEB. Wait a minute. Oh, AEB by itself is a straight angle. But that's not a supplementary angle. Supplementary angles are 2 angles whose sum adds to 180. We got AEB by itself is 180. Yeah, DEC by itself is 180. So that's the false one right there. Okay. And let's see, we've got time for maybe this one. All right. This is one of those overlapping triangle problems. What we probably are going to need to do is break this down. Not easy, but we can do it. So what I focus on first is probably this triangle right down here. Okay. What we have, I'm just going to draw this. If we have a 25 here, then we've got a 25 degree there because of vertical angles gives us that. Vertical angles are congruent. So now, and that's at angle E. If you're not tracking with me, I went B, E. Yeah, I'm at a different angle than there, but you know that's angle right here. Okay. So right there, I got a 25-degree angle. Now I'm going to focus just on this here. Okay, if you can track with me. Ignore everything else. We just found that that's 25 degrees from here to here. They're telling us this is 65 degrees, and they want the measure of angle D. Now, using exterior angles theorem is the fastest. We have a triangle with an exterior angle of 65, and what we have is the two remote interior angles must add to 180. So really all I got to do is take 65 and subtract 25 to get 40. Now I know it's going to be 40 because those two add up to 65. All right, how would most of you probably do this? My guess is instead you'll probably get the 65. You'll do 180 minus 65 to get 115 here. Then, of course, we'll add 115 and 25, and 180 minus 140 equals 40. That's just using linear pair and angles of a triangle add to 180. Both work, just one's probably more efficient than another. All right, so I'll stop this video and pick up the rest on another one.